Okay, so stoichiometry is the relationship of, it's how we convert from one, like a quantity of one substance to a quantity of another substance using balanced chemical equations, all right? So using that, that stuff from Unit 5 and Unit 6, that's where we're kind of bringing it together. All right, so in Unit 5, writing and balancing chemical equations. Unit 6, the mole conversions, like mass to mole, mole to volume, particles, that type of stuff. Okay, so it's bringing it all together. Like I said, we use stoichiometry to convert from a quantity of one substance to a quantity of another substance that are in a reaction together. Okay. So the coefficient ratio is what I call the bridge that is used to convert between substances using that conversion factor form, meaning like the fraction, the unit you're converting from goes on the bottom so it'll cancel, the unit you're going to goes on the top so it doesn't cancel. Okay? So we have this reaction. Let's just practice and review how to balance equations. And then we'll talk about how we're going to use them. So we have this reaction right here. And I'll put in the lines like what you have on your note sheet. All right. So in order to balance this, remember we write out the different elements that we have. So we have hydrogen, sulfur, and oxygen, right? Right now, on the left side of the equation, how many hydrogens do I have? 2. And how many are on the right? How many sulfurs on the left? On the right? And oxygens on the left? And on the right? 3. So my oxygen is the one that's not balanced. So remember, we can only use whole numbers for our coefficients. There's no whole number we can put in front of O2 on the left that will make this 3. Right? We can't multiply 2 by anything to make it 3. That's a whole number. So my hint for things like this is make it so that we have an even number of oxygens on the right. So what do you think we should do? I think that's a great way to start. Let's put a 2 here. So now how many oxygens does that give me? 4 on the right. And what did that do to the hydrogens? I now have 4 hydrogens. All right. We want to save oxygen for last because it is found as alone on the left, so that's going to be easier to balance here. Okay. So now, how am I going to fix hydrogen? Where? 2 in front of the H2S. So that gives me 4 hydrogens on the left. Ooh, what'd that do to the sulfurs? I have 2 of them. So how am I going to fix the sulfurs? Oh, that's messing up the oxygens again. Hopefully we can... Okay. So that gives me 2 sulfurs here. How many oxygens are on the right? 6. Because we have 2 times 2 plus 2 here, so that's 6. And then what do I put here? A 3. As Brennan said, that is easy. Okay, so if balancing equations is something that you need to review, please make sure you go back and do that. All right, all of the stuff from Unit 5 is still up on Vision. There's extra resources. Maybe print out one of the homeworks and redo it just to practice it, okay? Because we haven't done it in a little while. We haven't done it since January, so it's been a hot minute, okay? All right, so some examples of conversion factors. Now, what these coefficients mean, they do mean something, okay? What they tell us is the moles of those substances in the reaction. So in this reaction, I have, for example, 3 moles of oxygen gas. For every 2 moles of SO2. Or you might be able to compare moles of H2O to moles of H2S. I have 2 moles of H2O for every 2 moles of H2S. Or you could say you have 2 moles of H2S for every 3 moles of O2. And so on and so forth. Like those are just 3 random examples that we could pull from that. I'm just saying, like, that's what the coefficient means. It tells you the moles of that substance in the reaction, which we will then use in these conversions that we're going to be doing. Now, please make note of this. Never reduce conversion factors. Never reduce these fractions. It will save you a load of trouble. Like, you might, to eliminate errors, just use the numbers from the balanced chemical equation. Yes, 2 over 2 is the same as 1 over 1, but I'd rather you leave it as 2 over 2 than make a mistake somewhere. Okay? All right, so just like in Unit 6 when we had a mole roadmap, we have a stoich roadmap. You know, stoichiometry, shortened to stoich. We have a stoich roadmap for this unit, okay? Which is on the bottom of page 1, which you should be looking, like you can see. Which is also right here. All right, so substance A is whatever your given is. So this is our given. And this is our unknown. B is what we're converting to. A is what we're converting from. Okay. Now, within substance A, it is just the regular mole roadmap. Nothing changed there. Same thing within substance B. These conversions here are all the same as what you learned back in Unit 6. We're just adding this new step, which you did in the POGL. You did some of those, but we're going to review it. That's the new step. That's using the balanced chemical equation. Nothing else is really new for this unit. That we're just adding on, okay? So I've actually I rewrote it on the whiteboard so that when we're going through these problems, we don't have to keep flipping back and forth, okay? But you also have the roadmap in your notes, and if you ever lose your packet, remember it's always on Vision, okay? So let's go through some practice problems. Our first one we're going to do is going to be based off of that reaction that we just balanced on the previous page. This one, the 2H2S plus 3O2 goes to 2SO2 plus 2H2O. I'm going to rewrite that real quick once I get this together. There we go. So my reaction was 2H2S plus 3O2 going to 2, what was it, SO2 plus 2H2O? All right, that was my reaction, right? So, for that reaction, how many moles of water will be produced if 16.23 moles of oxygen are used and there's excess hydrogen sulfide? You're going to learn what excess means in a couple classes, okay? So what is our given? 16.23 moles of what? And how do I write oxygen? O2. This is where writing the label for the substance is really important. Writing the chemical formula for the substance or the label, that will help you hopefully eliminate errors. What am I asking you to find? What's your unknown? Moles of what? Moles of H2O, moles of water. So I'll jump back to the roadmap for a moment. Here, mole of A is where we're starting. That's our given. And we're going to moles of B. To get there, we're going to use that coefficient ratio. Okay? So, mole of A is O2, going to moles of B is H2O. And we're going to use that coefficient ratio to get us there, based on the balanced chemical equation. So when we set up our problem, 16.23 moles of O2, this is just like every other conversion we've done. Whatever unit you're starting with, where do you put it? On the bottom. Why do we do that? So it'll cancel out. So moles of O2 go on the bottom. And the unit that we're converting to goes on the top. So what do we put on the top? Moles of H2O. Now, the numbers for the moles come from what? Not the periodic table.
The first thing, the equation.
The equation, the balanced chemical equation. We use the periodic table when we have mass. That's going to come up in a couple problems, okay? So, in this chemical equation, how many moles of H2O are there? 2, because it has a coefficient of 2. And how many moles of O2 are there? 3, because it has a coefficient of 3. So now we've set up the problem. Now we can just solve. So you're going to take 16.23, multiply it by 2, divide by 3, or divide by 3, multiply by 2. Doesn't matter which one you do first. Moles of O2 are going to cancel, and we're going to be left with moles of H2O. And just like before, the sig figs of your given will dictate the sig figs of your answer. So how many sig figs will our answer have? 4. So what is 16.23 times 2 divided by 3? 10.82. Were you doing that in your head? I don't know if I believe you, the way you said that. Okay. So you should get 10.82 moles of H2O. Okay? How do we feel with that? Let's do another one. Are you ready for me to go to the next page? All right. Problems 2 through 8 are going to be using this reaction. The N2 plus H2 goes to NH3. Instead of changing up the reaction for each one, let's just practice using the equation. So for the rest of the problems we're going to be doing today, we're going to be looking at this reaction. In your homework, which you picked up on your way in, it has a different reaction each time, so you get the practice of balancing and writing equations. But for right now, let's just practice the new stuff. Okay? So for that equation, what do we need to do? So we need to balance it, right? So if you haven't already, take a moment to balance it. So when this is balanced, what do you get? 1, 3, 2. Alrighty. So reading the problem, what is our given? (6.3 times 10 to the negative 4 moles of H2. And what are we trying to find? Moles of nitrogen. What's nitrogen? N2. So my roadmap, I'm doing moles of one substance, moles of my given to moles of my own unknown. So it's the same as the last one. It's just the mole to mole. We're not adding on the other stuff yet. We're still just practicing this new thing. We'll add on in I think maybe the next problem, it might be in 2 problems, where we're going to add on doing like mass and stuff like that. So using the coefficient ratio, so we're just going to use the coefficients from the balanced chemical equation. So 6.3 times 10 to the negative 4 moles of H2. What unit will go on the bottom? Moles of H2. We want it to cancel. What unit goes on the top? moles of N2, because that's what we're converting to. Where do we get the numbers? The equation. So remember, back in Unit 6, every time we did a mole conversion, we always put a 1 with moles, because we were always converting within the same substance. Okay? And you're going to see that when we actually expand out on the roadmap. When we're within the same substance, we're always going to have a 1 with moles. When we're going from one substance to the other, we're going to use the coefficients from the balanced chemical equation. Right? So, how many moles of N2 are in this equation? 1. And that's just because that's what it was when it was balanced. How many moles of H2 do we have in this equation? 3. So now we're set up. Moles of H2 are going to cancel. We're just going to take 6.3 times 10 to the negative 4 and divide it by 3. Or multiply by 1/3, same thing. So what is that? 2.1 times 10 to the negative 4. What are your units? Moles of N2. And again, clearly indicate your final answer. Did you have a question?
Oh, no.
Oh, okay. All right. Questions on this? How do we feel with this? All right, so why don't you guys, before we expand out on the roadmap, why don't you guys try this one? It's the same reaction as before. So we had 1N2 plus 3H2 going to 2NH3. All right, same reaction as before. Figure out your given and your unknown and solve it. All right, so this is what you should get. So check to make sure you got it correct. All right, so now we're going to go beyond just a mole-to-mole step. We're going to add on the stuff we learned back in Unit 6, combining it with this new step. Okay? So, same reaction as before. Same reaction. So, what is my given in this case? 6.2 grams of NH3. And what am I asking you to find? Grams of H2. Whoops. 2. There we go. So my roadmap, I'm starting where? Mass A, and then I'm going to go to mole A, because it's the only place I can go, using molar mass in the periodic table. Then once I'm at mole of A, I can go to mole of B, using that coefficient ratio like we've been doing. And then I can go from mole of B to mass of B. That's what I'm asking you to find. So molar mass for the second substance, okay? So let me write that out. Mass of NH3 to moles of NH3 using the molar mass. Then to moles of H2 using that coefficient ratio. Then to mass of H2 using the molar mass. Okay. So how many steps is that going to be? 3. Every arrow is a step because we're starting with mass of NH3 and then one step to get to mole of NH3, a second step to get to mole of H2, a third step to get to mass of H2. So 3 steps. These take up a lot more space than, 1 or 2 steps, which makes sense. Yeah? Okay, so 6.2 grams of NH3. I need to get to moles of NH3. This is a mole conversion like we learned back in Unit 6. What unit do I put on the bottom? Grams of NH3. And what unit do I put on the top? Yep, moles of NH3. And yes, we're going to put a 1 with that because we're within the same substance. All right, because our conversion from a quantity of one substance to a quantity of that same substance, a different unit, like grams to moles, it's always going to be 1 mole. It's when we use it's when we go from moles of NH3 to moles of H2 that we'll use the coefficients. How do I figure out the grams of NH3? Use the periodic table and calculate the molar mass of NH3. Nitrogen is 14.01. Hydrogen is 1.01, and there are 3 of those. So what is our total molar mass for NH3? 17.04. Good. All right, so I've taken care of the first step. Now my second step. What unit do I put on the bottom? Mole of NH3. And what unit goes on the top? Mole of H2. Where do I get these numbers from? The balanced chemical equation, which I have written back here. How many moles of NH3 are there? Of NH3? There are 2 NH3s because its coefficient is a 2. And what coefficient did H2 have? 3. Okay. So I've taken care of the second step. And now my third and final step is going from moles of H2 to grams of H2. What do I put with moles? 1. And I calculate the molar mass for the grams, which is 2.02. So that took care of the third step. So grams NH3 cancel, moles NH3 cancel, moles H2 cancel, and we're left with grams of H2. You're going to multiply by everything on the top and divide by everything on the bottom. When I do this, what I actually do is some people, they do like all the multiplication of the top and they write that number down, and then they do the multiplication of the bottom and write that number down and then divide. That's fine. You can just do it as one big thing in your calculator. I just do everything as I get to it left to right. So what I physically type in my calculator is 6.2, and then I divide that by 17.04, and then I multiply that by 3, divided by 2, and then multiply that by 2.02. And the calculator knows that it's, doing the whole thing multiplied, doing the whole thing divided. Okay? How many sig figs? 2, because we started with 2. Nothing else in the problem will dictate the sig figs, only the given. And what do you get? Are we there yet? 1.1? What? Okay. 1.1. 1.1 grams of H2. So that means that in order to produce 6.2 grams of ammonia, NH3, we had to react at least 1.1 grams of H2 to produce that much. Okay? How do we feel with this? All right, the next one is the same type of process. Same reaction. It's going from, what is our given? (1.5 times 10 to the second grams of H2), and I'm asking you to find grams of N2. So this is going to be the same type of problem in terms of the roadmap. Same steps. The numbers are going to be different though. So why don't you guys practice this one in your groups and make sure you can do the process. Use number 4 as your sample to help you through it. All right, so this is what you should get. So yeah, converting 1.5 times 10 to the second grams of H2, we'd first convert that to moles of H2. Molar mass of H2 is 2.02. Then convert that to moles of N2. using the coefficient ratio, gentlemen, and then to grams of N2, they're grams of N2. Molar mass of N2 is 28.02. The reason it's 690 and not 693.4 or whatever it was that you get in your calculator is because of significant figures. We only had 2 to begin with, so we can only have 2 here. So the 693 rounds down to 690. That 0 is not significant. If it was 690 point, that would be 3 sig figs. That decimal point makes that 0 significant. Okay? Now, the other problems that we didn't quite get to today, which is fine, I didn't actually get to them with my other classes either. It's all the same type of stuff. It's all using the roadmap. We didn't do any particles and volume stuff, but you already know how, or let me rephrase that. I've already taught you how to do that back in Unit 6, so you're just bringing it all together, okay? So for homework tonight, start working on that, the stoichiometry worksheet. Remember, next class, we're doing the lab for your block. You just need to dress appropriately, okay?